Okay, this section is all about calculating the angle between two different planes. And it's pretty clear that two different planes are either parallel to one another, like this, or they're not. And if they're not parallel to one another, they have to look like this, with some line of interception. Now note that the only reason they've been drawn as boxes is just because it's a picture, but in reality it extends on forever in all of the two dimensions that the plane is defined by. Now, if the two planes are parallel, their normal vectors will either be the same or multiples of one another. And if the two planes are not parallel, then they will share a straight line, but they will also have two different normal vectors that are not multiples of one another. So, the angle between two planes. The angle between two planes is the same as the angle between their normal vectors. Notice that there are actually two angles between their normal vectors. This corresponds to the, well, if you were to continue this bottom plane on, then this theta 2 angle would correspond to this angle here, theta 2. Now this is still an angle between the two normal vectors, but usually when we're asked to find the angle between two planes, we give the acute angle. There are two angles if the planes are not perpendicular. So, in summary, finding the angle between two planes is the same as finding the angles between the two normal vectors using the dot product and just giving the acute angle. So let's do an example, exercise 6.13. Find the angle between the plane pi1 with this equation here, it's in vector form, and the plane pi2 with this equation here in Cartesian form. So we already know the normal vector or unnormal vector for pi2. It's 3, 2, negative 4. Now we just need a normal vector for pi1. We can do that by taking the cross product of the two direction vectors of pi1. So n1 is equal to 4, 3, 1 crossed with 7, 6, 4. So 3 times 4 is 12, minus 6 is 6, and then 7 times 1 is 7, minus 4 times 4, so that will be minus 9. And then 4 times 6 is 24, minus 21 is 3. And that's clearly the same as 3 times 2, negative 3, and 1. So all we got to do now is find the angle between this vector here, 2, negative 3, 1, and 3, 2, negative 4. We can do that by taking the dot product. 2, negative 3, 1, dotted with 3, 2, negative 4 is equal to 2 times 3 is 6, minus 3 times 2, so that would be 0, and then minus 4. So minus 4, and we also know it's equal to the length of the first vector, which is the square root of 2 squared is 4, plus 9 makes 13, and 1 makes 14, times the length of the second vector, so 9 and 13 and 16 makes 29, and then times cosine of theta, where theta is the angle between the two. And so we have that theta is equal to cosine inverse of negative 4 divided by root 14 root 29, and that is equal to 101.45. But usually we take the acute angle. So if we have our two planes that look like this, and the other one maybe looks like this, then it intercepts along this line here. Get the idea? Then what we have calculated is clearly this angle here, which is 101.45. To find the angle that we want, the acute angle, we can simply subtract that from 180 degrees. So the angle alpha between the two planes is 180 minus our answer, which is 78.5 degrees to 1 decimal place. So that concludes exercise 6.13.